Next, let's talk about Descartes' rule of signs. Now, Descartes was a Greek philosopher and mathematician, and he figured out that I can determine how many of my answers should be positive and how many of my answers should be negative based on the sign change. And this deals with our real zeros, our real numbers. This does not deal with our imaginaries. So he said, based upon the sign change, I can determine possibly how many of my answers are going to be positive and how many should be negative. So this is just a polynomial to show if you had f of x equals 2x to the third minus 4x squared plus 2x plus 7. Now, he says to determine the possible number of positive zeros. Count how many times you change signs. Well, 2x to the third is positive. If you want to put a plus there, it's positive. Then we go to a negative. That's one sign change. You changed. Okay? So you count that as one change. Then we're negative, and then we go to a positive. That's a second change. You change signs. Now this last one is positive to positive. That's not a change, okay? Plus to plus is not a change. It has to go from plus to minus or minus to plus. So we technically only changed twice. We went from positive to negative. That's one change. Negative to positive, that's my second change. So Descartes says you have a possibility of having two of your answers being positive, or none of your answers are positive. Okay? Now, how did I get that or zero? I know I have two numbers that's positive because I changed twice. Now, Descartes also knows that our imaginaries and our irrational numbers come in pairs. They come in pairs, plus or minus. That's two answers. So Descartes says you always subtract 2 to get your next possibility. So let me say that again. He knows that they're coming in pairs. So Descartes says, okay, if I know I'm going to change twice, that's my first possibility. I got two numbers that's positive. He said to get the next possibility, you're going to subtract 2. And that will leave me at 0. And you know you can't go any further than 0 as far as possibilities because you're going to go negative. And you don't want a negative. You can't have a negative possibility. So we stop at 0. So that's how we get 2 or 0. Now to find our possible negative zeros, Descartes says in the place of x, you need to plug in negative x, okay? And evaluate the sign change. So back into this polynomial, you have 2, and I'm going to do it in red. I'm going to plug in negative x. Okay, so where I had positive x, I plugged in a negative x. And we're going to evaluate it as if it was a negative number. So negative, any negative number raised to the third power is going to come out a negative. Do you agree? Any negative number raised to the third is going to come out negative. And since 2 is still positive, it just makes it all be a negative, okay? Any negative number raised to the second power comes out positive. So a positive times a negative makes that stay negative. And a negative times a positive is negative 2x plus 7. So he says, once you have evaluated that negative x, now count your sign change. Well, my first 3 numbers are negative. There's no change here. I'm not changing to a positive. I don't change to here at the end. I go from a negative to a positive. That's one change. So I have the possibility of having, and I'll write it in green, one number that's negative. Okay? Now, I don't have to see the plug-in of negative x. I would want you to use a little math common sense. You have 3 possible answers. So I should be able to look at the polynomial and count the original sign change to give me my positive. I go from a positive to a negative to a positive. I change 2 times. So I know 2 out of my 3 answers have to be positive. I want you to think about that. You got 3 possible answers. 2 of them are going to be positive. That only leaves me with 1 anyway that can be negative, without me doing this whole plug-in of negative x. So you see that. I have 3 answers. 2 of them are going to be positive. 1 of them can only be left to be negative. Now, I wouldn't subtract 2 from 1, because wouldn't that put me at a negative possibility? So all I can do here is say I have 1 negative 0. I do not subtract 2 from 1. I stay at 1. It has to be at least 2 and bigger for me to subtract 2 to do a second possibility. So we're going to use Descartes' rule, and that kind of helps us in eliminating what numbers to pick or not to pick. Because you might have a polynomial where none of your answers are going to be positive. That means that you don't need to plug in or do synthetic division with any positive numbers. What you need to plug in are the negative numbers. So that Descartes helps in eliminating possible choices. So now let's use this on the next example. So this would be example 6. Let's do f of x equals 8x to the 4th minus 26x to the 3rd minus 27x squared plus 11x plus 4. So we're going to develop that list of possible zeros. P over Q. My P is 4. My Q would be 8. And 4 and 8 have numbers in common. So again, we're going to have some things to reduce. So with my p's, I have positive, negative 1, 2, and 4. With my q's, I have positive, negative 1, 2, 4, and 8. So when I develop this list, you do not want to repeat yourself, and you want everything in lowest terms. So I know my tops, my p's, plus or minus 1, 2, and 4. Those are your whole numbers. They're also the tops of your fractions. So that's going to be with 1 on the bottom. Put 2 on the bottom, and I only can write 1/2. 2 over 2 reduces, 4 over 2 reduces. Just in case you don't see what I'm saying. 2 over 2 is 1, 4 over 2 is 2. So I would erase those because I only want the ones in lowest terms. Next, put 4 on the bottom, and you have 1 over 4. 2 over 4 and 4 over 4 you can erase. 2 over 4 is 1/2, and 4 over 4 is 1. You already have those. Okay. Lastly, on the bottom is 8. 1 over 8, 2 over 8, and 4 over 8. And again, 2 over 8 reduces to 1/4, and 4 over 8 reduces to 1/2. I already have those, so I will erase. So this would be my list in lowest terms of the numbers that I can pick from. And keep in mind you have plus or minus on each one. On the 1, the 2, the 4, the 1/2, the 1/4, and the 1/8. Now, I would want to see how many of my answers are supposed to be positive and how many are supposed to be negative. Let's do Descartes' rule of signs. And I'm going to put a P plus for possible positive and a P minus for possible negative. So sign change. We go from a positive to a negative. That's one change. Negative to a negative, that's not a change. Negative to a positive, that's a change. That's my second one. Positive to a positive, that's no change. So I didn't change but twice. I only changed signs 2 times. Okay, I'll do that again. That 8 is a plus, it's a positive. So a positive to a negative is one change. Negative to a negative is not a change. Negative to a positive is a change. That's my second one. And then positive to positive is no change. So I have the possibility of having 2 of my answers being positive or none of my answers are positive. Descartes says subtract 2. And that's how we get the 0. Now, you got to come up with 4 answers. So this is what I want you to be able to do is just common sense math. If I got to come up with 4 answers, if 2 of them have the possibility of being positive, that also leaves me with 2 that can be negative. Because 2 plus 2 equals 4. The lead of your possibility has to equal your total number of zeros. Or none of them. Now that wouldn't be a fun problem if you had 0 on the positive and 0 on the negative. That means that they're all going to be complex or irrational. And I'm not going to give you a problem like that. So my Descartes' rule of signs, I just counted. I only changed twice. So that affected my positive possibility. And I just subtracted. If I know I have 4 total answers, 2 of them, since I did my change count, are going to be positive. That only leaves me with 2 that could be negative. Okay? Now, that doesn't help me with picking my numbers because I got a 50-50 chance. So We're just going to pick. 50-50 chance. So I'm going to erase this so I have enough room to show you the ones that work. So, I got my little house. Check to make sure you're not missing a term and you're in descending order. And I am. So I have 8, negative 26, negative 27, 11, and 4. Bring down the 8. So we can start with, let's try 4. Okay. So we have 4 times 8, which is 32. 32 minus 26 will give us a positive 6. 6 times 4 is a positive 24. Minus 27 is negative 3. Negative 3 times 4 is negative 12. Plus 11 is negative 1. Times 4 is negative 4. Minus 4 is 0. So this last column zeroes out, so we know that 4 is an answer. Now keep in mind, this represents 4th degree. So this row is just 3rd degree. So you want to do your synthetic again, and we're going to draw our house from that row. You don't want to start all the way back over because you'll never get to the 2nd degree mark. So from this row, we're going to try, let's do 1/2. So we're going to bring down that 8. And so half of 8 will give us 4. 6 plus 4 will give us 10. Half of 10 will give us 5. 5 minus 3 will give us 2. And half of 2 is 1. And negative 1 plus 1 is 0. So again, that column zeroed out. So now, this would represent my square. Keep in mind, we are decreasing it by 1 degree. So we are at 2nd degree, so we can stop with our synthetic. And this would be 8x squared plus 10x plus 2 equals 0. To factor, we're going to take off a 2, and that would give us 4x squared plus 5x plus 1 equals 0. And again, this is an easy factor. We are adding to get our 5, and we're going to use 4x and x and 1 and 1. Because 4 times 1 gives us 4x, and that's 1x, and together that would make 5x, and both of them are positive. So we know that this would give us a negative 1/4 if you set it to 0, and the second one would give us negative 1. So our 4 answers would be negative 1, negative 1/4, 1/2, and positive 4. And if you remember what we said about Descartes, he said we changed twice, so 2 of your answers should be positive. Positive, positive. And that means the other 2 should be negative. And so he was right. We have 2 negative answers and 2 positive answers. Let's look at another example. Example 7. F of x equals 2x to the 4th minus x to the 3rd plus 7x squared minus 4x minus 4. So we're going to do our list of P over Q. Our P would be the factors of 4, which would be positive, negative, 1, 2, and 4. And our Q would just be positive, negative, 1, and 2. So we have common factors, but it's going to be a small list because you don't have that many numbers. So our tops would be positive, negative, 1, 2, and 4. Those are my P's. Those are my whole numbers. And that's what I would have if I put it over 1. So the only Q I have is putting 2 at the bottom. And if I put 2 at the bottom, I have 1 half, 2 halves, and 4 halves, which 2 halves is 1, 4 halves is 2. I already have those, so they can be erased. And I'm a little OCD. Let me put that back in orange. So that's our list. We have very few numbers. Now, keep in mind, I got to come up with 4 actual answers. So I have a very, very short list. Now, let's do Descartes' rule of signs. How many should be positive and how many should be negative? So let's count our sign change. We start off with a positive 2x to the 4th, and then we go to a negative. We change 1 time. That's 1 change. Then we go from a negative to a positive, a minus to a plus. That's another change. That's our second change. Then we go to from a plus back to a negative. That's our third change. And then you have negative to negative. That's no change. So I changed 3 times. So that means 3 of my answers should be positive. Or only 1 of them is going to be positive. Now on the other one, I had 2 or 0. Keep in mind you're subtracting 2. So 3 minus 2 gives you 1. That's how I get 1. And I wouldn't subtract 2 again because you're going to go negative. So kind of think of it like this. If your count or your change is an odd number, like 3, then you're going to have to stop at 1. If your change or your count is an even number, like 2, then you're going to stop at 0 as far as your possibilities. Now, my total number is 4. So I like drawing these sticks. So if I changed 3 times, so that means 3 of my numbers are supposed to be positive. Well, that doesn't leave but 1 poor person that can be negative. Do you see that? So my possibility for my negative is just 1. And I don't subtract 2 from 1 because I'm going to go negative. That's the only possibility I have is 1. Okay? So now let's do a little synthetic. I'm not missing a term, so I got 2, negative 1, 7, negative 4, negative 4. Bring down my 2. So we got a very, very small list. So let's try, let's try 1. 1 times 2 is 2. 2 minus 1 is 1. 1 times 1 is 1. 7 plus 1 is 8. 8 times 1 is 8. Minus 4 is 4. And 4 times 1 is 4. Minus 4 is 0. So it works. Last column is 0. So we know 1 is an answer. Okay? So we're going to go, that's 4th degree. This represented x to the 4th. So this is just 3rd degree. So this time, let's try negative 1/2. So we know a negative and a positive would give me a negative. Half of 2 is 1. So 1 minus 1 is 0. 0 times anything is 0. But plus 8 is 8. A negative and a positive we know would be a negative. Half of 8 is 4. And 4 minus 4 is 0. Again, there is no remainder. So negative 1/2 works. So now, this represents my 2nd degree row. So we have 2x squared, no x term, plus 8. Now, you don't have 3 terms to factor. This is only 2. So we're going to do another method. We're going to do the square root method to get our answer because we have 2 terms, not 3. So you're going to get x by itself by subtracting 8. We're going to divide by 2. And I'm out of room. I'll write it over here. That's going to give us x squared equals negative 4. Now, to get x by itself, we're going to take the square root. And that's going to give us x equals square root property plus or minus. Square root of negative 4 is 2i. That's our last 2 answers. And you see they're imaginary because it's got an I on it. Okay? So, our 4 answers for this problem, we have a negative 1/2, we have a positive 1, and we have plus or minus 2i. That's 4 answers. Now, I want to show you how to card. This needs to make sense to you. Do you see he said you either going to have 3 numbers that's going to be positive or only 1 number that's positive? He knew from the jump that this, oops, let me put that mark there. This imaginary number, do you see it comes in pairs? That's 2 numbers. So that's the reason why we subtracted 2. And you see you only got 1 number that's positive, which is 1. 1 positive. And I only had 1 negative number. The other 2 numbers, ding, 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 that's the reason why we subtracted, are complex. They're imaginary. Okay. Example 8. F of x equals 2x to the 5th plus 11x to the 4th plus 16x to the 3rd plus 15x squared plus 36x. All right, now I hope you notice that for one, we're in 5th degree. Okay, I wanted to show you an example of a huge polynomial that's going to have 5 answers, okay? Also, when I do my list and I get ready to go and do P, my whole number, constant number, is not there. I hope that you see that every term has an X. So this one has a GCF, and you need to take it off. If you take that X off, then 36 will be your whole number, okay? So we're going to factor off an X so we can have a true P, okay? Because everybody has an X. So this one has a little different swing to it. Kind of do a little erasing here. Okay, so let's take off that X. And so that decreases us to 4th degree. Do you notice all of our degrees go down when you take that X off? That way you have 36 as a true P. Now, let me explain this to you. Keep in mind this whole thing is set equal to 0. So when you factor off an X, this is real important information. One of your answers is 0. Doesn't it say X equals 0? When you factor it off, one of them is 0. So you're only left with 4 more answers to find. So when you do your listing of answers, 0 has to be in that list because you factored off an X, which brought you to 4th degree. That means for you to jump from 5 to 4, one of your X's is already found, which is 0. So that helps us out. We don't need but 4 more answers. And I can do my list with my P over Q. Because now 36 is a true P. My Q is going to be 2. Which, I'm trying not to, is just 1 and 2. Hope y'all can see that. Now 36 has a few factors. 36 factors. We got 1, 2, 3, 4, 6, 9, 12, 18, and 36. Those are all the numbers that go into 36. So when you do your list, that's all of your whole numbers, your P's. 1, 2, 3, 4, 6, 9, 12, 18, and 36. And then I need to take all these numbers and place them on top of 2. Now, by now you should know if they're both even, you don't need to write it. So I'm going to write 1/2, 3/2. I don't need to write 2 over 2, 4 over 2, 6 over 2. I can do 9/2, but I don't need 12/2, 18/2, and 36/2. So this would be my list of possible zeros. And you got the positive and the negative for all of these numbers. Now, according to Descartes, let me show you this. Now look at this polynomial. Now we're not going back to the original because that one included 0. Keep that in mind. 5, fifth degree, includes the 0. So I have to go from the one in parentheses, the 4th degree. Everything in this parenthesis is positive. So do I ever change signs? No. So if I was doing a possible positive and a possible negative, I don't have a sign change. Everybody up there is positive. So if I don't change, that means none of my answers are going to be positive. I never change to a negative. So that means that out of the 4 answers that's left, you got 4 left, all 4 of them going to be negative. Or subtract 2. 4 minus 2 is 2 of them going to be negative. Or none of them are negative, 0. So this one had 3 possibilities because my chance was higher. So if you say 4 minus 2, you get 2. So that's the reason why I got that one. And then when you say 2 minus 2, you get 0. So you have to keep going till you get to 0 or 1. So keep in mind, if it's an even number, we're going to stop at 0. If it's an odd number, we're going to stop at 1. So we have the possibility of having 4 numbers, 2 numbers, or no numbers that's going to be negative. Wow. So you shouldn't even try any positives. None of the positives work. Now, let me give you another hint. And I'm going to have to do a little erasing off of my box so I can show you in one screen how to do your synthetic. But something to add my numbers down here because my box was way too big. Okay. So I'm going to erase this a little bit so I have enough room. So now we're going to do our synthetic division. And I got 2, 11, 16, 15, and 36. Bring down my 2. All right. So we're using only negative numbers because we said the positives are not going to work. So let's try -3. So -3 times 2 will give us a -6. 11 minus 6 will give us +5. 5 times -3 is a -15. 16 minus 15 is 1. 1 times -3 is -3. And 15 minus 3 is 12. And 12 times -3 is -36, which is a 0. No remainder. So keep in mind this was x to the 4th degree. So we're going to do a row here. And that will bring us to that's the 3rd degree. Because I want to keep going until I get to 2nd degree. That's your key, is to stop when we are at 2nd degree. Okay? So when you have a polynomial that's this big, really fourth degree, fifth degree, some third degrees, but especially in your fourth and fifth degrees, you can have multiple answers to work, meaning -3 could work again. Okay, there's no harm in trying it because that's something called multiplicity. The likelihood that you have a whole bunch of different numbers to work is very slim. You probably have more than one, you probably have multiple of the same number that work. So try it again. There's no harm in trying numbers more than one time, okay? So again, that's called multiplicity. Multiplicity. You can have one number work 2 times or one number work 3 times. So let's try -3 again. So we got -3 times 2 is -6. 5 minus 6 is -1. -3 times -1 is 3. 3 plus 1 is 4. And 4 times -3 is -12. Plus 12 is 0. So see, it worked a second time. So -3 is considered a multiplicity, okay? A multiplicity. And I'm going to spell that out for you guys so you'll know what I'm saying. Multiplicity. Okay, -3 is a multiplicity. It works twice. Okay? So I'm going to erase that word so I have some room here. So we know it worked twice. Now, this was x to the third row? And this would be x to the second row. So we can stop with the synthetic. So this would give us 2x squared minus 1x plus 4 equals 0. Now, 3 terms, you would want to factor. So we're adding to get 1. Well, 4 and 2 add and give you 1? No. Okay? So this does not factor. So I wanted to show you that there are other methods you're going to have to do to get your answer. So I'm going to erase my synthetic division, and I'm going to write over here on the side, I already know that -3 worked twice, okay? So I'm going to erase. So we can see the method I'm going to use to find my next 2 answers. So we have 2x squared minus 1x plus 4 equals 0. Now, since it doesn't factor, we're going to have to do the quadratic formula. So we know the quadratic formula is minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So keep in mind the quadratic formula is always used when stuff doesn't factor. So we know that this will be A, B, and C. So we're going to straight plug in those coefficients. So we have minus -1 is our B, plus or minus the square root of B, who is -1 squared, minus 4, times the A number, who is 2, times the C number, who is 4, all over 2 times the A number, who is 2. And that's just plug in. Now we're going to clean it up. 2 negatives on the front, make a positive 1, plus or minus the square root, -1 squared is going to produce a positive, and you're going to multiply all 3 numbers together. -4 times 2 times 4. -4 times 2 times -4 is -32. All over 2 times 2, which is 4. Finish your radical. We have 1 plus or minus the square root. 1 minus 32 is a -31. All over 4. And then you're going to pull your chart out, and you're going to see that 31 is prime. There's not a perfect number in 31. There's not a factor in 31. But you must take out that negative. You can't have a negative under a square root. So your answer would be 1 plus or minus I square root of 31 all over 4. And that's 2 answers. Okay, keep in mind that's 2 answers. I write it over here. That's 1 plus I square root of 31 over 4. And that's 1 minus I square root of 31 all over 4. Okay, these are your other 2 answers. So going back, we know we have -3 twice. And that's going to represent the card saying you got 2 numbers that's negative. You didn't have 4 that was negative. You got 2 of them that's negative. Now we also got to include in our answer 0. Okay? And we just found 1 plus or minus I square root of 31 all over 4. Those are your 5 answers. And so I've showed you where when things don't factor, like this one, it does not factor. You got to do the quadratic formula. Okay?